Welcome to this video. What we're going to be doing is we're going to be talking about transformations of exponential functions. And when we're working with some of these exponential functions, I'm going to teach you the rules, but what's nice is you have access to the Desmos graphing calculator, and you're more than welcome to double check your answers with Desmos. But what's nice too is if you do know the rules, it'll help everything go faster, where just like, if you know your multiplication facts, you don't always have to use that calculator. So again, that's the point of learning some of these rules. So what we're going to start is we're going to start with the vertical translations of graphs of exponential functions. And I want to know, how does the value of k affect the graph of f of x equals 2x plus k? If we take a look at our graphs, we have f of x equals 2 to the power of x, g of x equals 2 to the power of x then plus 3, and then j f of x equals 2 to the power of x minus 3. So what we're going to do is, I have the graphs up here on your notes for you. What we're going to do is fill in our table and go from there. So what we can go ahead and do is use Desmos to help us for this. And so I'm going to minimize this screen. And I have, so kind of just shifting a few things around. Whoops. And so here I have Desmos. And I have the three equations that we're talking about and their corresponding graphs. And so take notice that the vertical shift of them, when you see them lined up on top of one another, that the growth rate does not change. It's just, again, that vertical movement, okay? So notice how we have the plus 3, it goes up 3 units, minus 3, it goes down 3 units from our function f of x equals 2 to the power of x. And so what I am asking that you guys do is go ahead and fill in that table. And so what we can do is we can go ahead and take a look at the table for each of these and go from there. So I'm going to go ahead and flip to the Smart Notebook. I'm going to actually make it bigger so it's easier for me to write. And let's go ahead and put this in. So when 2 of x to the power of negative 2, I get 1/4, then 1/2. To the power of 0 is 1. To the power of 1 is 2. And the power of 2 is 4. And so when we have 2 to the power of x plus 3, we should see a vertical translation of plus 3. All of these values increased by 3. And so if I jump back to Desmos, I scroll down and I take a look at the table on this equation, notice that yes, all of these values are increasing by 3 units. So we can come back to our Smart Notebook and fill that in, that they are increasing by 3 units. So I have 3 1/4, 3 1/2, 4, 5, and then 7. And so hopefully you realize the connection here when I'm subtracting by 3. So I'm going to jump back to Desmos and go to the table of where we subtract by 3. We look at these values, that each of these decrease by 3 when we compare it to our f of x of 2 to the power of x. And so again, if I have 4 and I subtract 3 from it, I get the 1, and I can do that all the way through with my values. So let me go ahead and write this in. And what you guys would do is use Desmos to help you for your homework if need be. So for g of x, I get negative 2 3/4, negative 2 1/2, negative 2, negative 1, and positive 1. Let's go ahead down to this first part where it says, when a graph is translated vertically, how is a y-intercept affected? And so we'll go ahead and use what we see in our table, where when k is positive, okay, so we had to the plus 3, when k is positive, the y-intercept moves up k units. Okay. Now, when k is negative, the y-intercept moves down k units. Okay? And so we'll talk about this more next time when I see you in class. And go ahead and turn the page. Over here we have horizontal translations of graphs as exponential functions. And so how does adding or subtracting a constant to x affect the graph of the general exponential function? And so we're going to do the same thing. We're going to compare these graphs. Now I'm going to come to Desmos and show you exactly what we are going to do here. So I'm going to go ahead and delete these out. And we have our original of f of x equals 2 to the power of x. Now when I put in my next equation, so this is important, we're going to have 2 to the power of, and when it is a horizontal translation, we need to make sure we are using parentheses. If we do not use parentheses, it will not work. So I'm going to change the color of this one real quick, and we'll go ahead and make this one blue. And then let's do the other one that we have here where it is 2 to the power of, and then again using the parentheses, x plus 5, and those parentheses. Not good. This one has red for us. So notice again, this time we have a horizontal translation. Let us go ahead and fill in the table of these values, and then we'll talk about this some more. Oops. So coming back real quick, filling in these values. This is the same that we had on the front side where we have 1/4, 1/2, 1, 2, and 4. On our next one, if I go back to Desmos and take a look at this at the table, I want you to see something. Here we have all these decimals. Remember how I said none of these yucky decimals in our notes? Let's go ahead and figure this out with fractions. So if I put -2 in for x, I'm going to have 2, oh, let me use a different color, sorry. I'm going to have 2 to the power of -7. We don't write things with a negative exponent, so we flip it. 1 over 2 to the 7th. 2 to the 7th is 128. So it's 1 over 128. And then we'll go ahead and do this. If I put -1 in for x, I get 2 to the negative power of 6, which is the same thing as 1 over 2 to the 6th. And so 2 to the 6 is 64. So I have 1 over 64. And we'll go ahead and keep doing this all the way down. I put 0 in for x, so I have 2 to the power of -5. And so it's 1 over 2 to the 5th, which is 1 over 32. So 2 to the -4th is now 1 over 16. And then 2 to the -3rd is 1 over 8. And then we'll go ahead and do to the 5th power, or x, 2 to the power of x plus 5. Now if we look at this on Desmos, we are not getting decimal answers. So we can go ahead and copy this straight into our notes. And so if you remember, we had 8 and 16. When x is -2 and x is -1. When x is 0, we get 32, 64, 128. So scrolling down here real quick before we go on, what I want to point out is when we have our h subtracting our exponent, okay, so x minus h, what it is doing is it's moving to the right. Okay. And then when we have x plus, it should be H, but Desmos wouldn't let me use the same variable. But anyway, when we're adding H to it, we are moving to the left. Okay, so it corresponds with that black one, and then this one corresponds with the red line. Okay, and we'll explore this and play with this some more next time I see you in class with our horizontal translations. And then the last page is comparing. And so again, we'll do that together next time I see you in class.